Hello everyone! Today, we are going to break down a fundamental concept in chromatography called theoretical plates. It might sound a bit technical, but it's actually a very useful way to understand how well a separation works. First, let's quickly remember that chromatography is a technique used to separate a mixture into its individual parts. The goal is to get nice, sharp, well-defined peaks on our chromatogram, not wide, messy blobs that overlap. So, how do we measure the quality or efficiency of the separation? That's where theoretical plates come in. The best way to understand this is with an analogy. Imagine your chromatography column is not one continuous tube. Instead, picture it as a long staircase with many, many tiny steps. Each one of these steps is a theoretical plate. These plates are not real, physical objects inside the column, they are a concept, a mental model to help us visualize the process. As your sample mixture travels down the column, carried by the mobile phase, it goes through a series of these tiny, imaginary equilibration steps. At each plate or step, the components in your mixture have a chance to distribute themselves between the stationary phase, the stuff packed in the column, and the mobile phase, the moving solvent. This process repeats over and over again, at every single theoretical plate, all the way down the column. The more of these plates you have, the more opportunities the components get to separate from each other. A column with a very high number of theoretical plates is considered highly efficient. It will produce very sharp, narrow peaks, meaning the separation is excellent. On the other hand, a column with a low number of theoretical plates is inefficient and will give you broad, poorly resolved peaks. We often talk about two key values. First is the plate number, symbolized by n. This is the total number of theoretical plates in a column. A bigger n is always better. A high-performance column might have an n value in the tens of thousands. The second value is plate height, or HETP, which stands for height equivalent to a theoretical plate. This is simply the length of the column that corresponds to one theoretical plate. For plate height, a smaller value is better because it means you can fit more plates into the same column length, making it more efficient. So, to sum it up, theoretical plates are an imaginary measure of a chromatography column separation efficiency. More plates mean better separation. Thank you so much for watching. If this video helped you understand theoretical plates, please give it a thumbs up and consider subscribing to the channel. Your support is greatly appreciated and allows me to make more science content for you. See you in the next one.